Alright, this is absolutely insane. We're just doing a real quick one right now. So we're showing the waveform and we're showing the stuff. So this is right now DC, purely powered off the battery. There's nothing going on. If I want to zoom way in, then there is like this little bit of noise that the coil picks up that's just from the room. It's like a radio station or something. I don't know what it is. That is just this incredibly tiny background ambient thing that the coil is kind of magnifying to a level where it's detectable. But we're actually powering that light with just DC. And then what we're going to show is I can engage the trigger. First of all, this transistor is so high quality. It's so special that it's such a high quality transistor that just by holding one end of this in my left hand and then touching this with all of these resistors, okay, all of these resistors, I can touch the last one and it triggers. It works a little, it works the same no matter where I do it. It makes no difference. It works the best if I touch it up there, I guess. So just by touching this, it's being triggered from this end through my whole body, from one arm, one hand, all the way through my body to the other hand. Okay, I'm putting it here in my left hand, and then I'm also just holding the phone with the left hand, and I can trigger. That's just DC power right now. I can trigger this. It's so sensitive. It's so incredibly sensitive that I can trigger it with my whole body resistance and through all this whole line of resistors. This is just a 200 ohm variable cranked up all the way to 200 ohms. This is like freaking hundreds of ohms. One of these, I forgot which one, is 6,800 ohms, or 680 kilo ohms. Yeah, 680,000. Some of these are 6.8 thousand. These are like thousands of ohms right here. My whole body from the left hand to the right hand. And I think it's possibly just because the frequency is so high. See, what's the difference now? Positive, negative. See, why are we getting that again when I was getting that sine wave one? What is the difference here? But the point is, I can trigger this just by touching it, and then you'll see that waveform. It's very interesting. And yeah, I guess we're actually on the negative side right now. So we're on the negative side, but I'm triggering this from my other hand to this hand. And I can do it through all of these resistors. So that's an extraordinarily sensitive piece of kit right there. It's insanely sensitive. Now let me probe the. This is actually a negative. So I'm doing something wrong. That's supposed to be positive. No, yeah, it goes negative, negative, positive. That's right. That's positive. Oh, look at that. See, I mean, okay, I'm only holding one side now. You see, the other end, the trigger is actually over here. It's this wire, which is going here to here, and I'm not How did I get it that sensitive? What was I just doing? What the heck did I just do? Whoa. So it's getting this just by touching this, which is a trigger wire that doesn't go to the actual trigger yet. We're getting this signal in the coil. Where is that coming from? I don't know. How do we have that much of a voltage on us right now? I touch here, touch here. I go like that, it turns on. There, it turned on. Just do this. Press auto. Okay, that takes energy out of it. There's a flash when I touch it. On this side, that is weird. Oh, just by touching that. And I'm only touching so that is the trigger wire. I can just touch it. One tap. That is insanely. So you see how it loops the energy. It takes a while. It self-triggers for a while just from touching it. Let me put this back on. It doesn't, yeah, the scope's throwing it off because it's grounded or something. The scope is throwing it off. If I touch the trigger wire, take the scope off of here, just by touching, no, it doesn't work. So just by touching this in one hand, and then I can touch the trigger, just a tap of my finger, and it goes all the way up to there. And if I drop that end of it, it still stays lit, just not as bright. If I let my finger go, it goes back to just, you see. So we're able to trigger this off of a finger. And then you can see it's going into such a resonance that it self-triggers for a while after just a touch. And I'm no longer touching the other end. This is the other end. Wow, just from touching the cord itself. So there's some kind of really trippy phenomenon going because of the high frequency, or because this transistor is just so, wow, it works better through the insulation. I mean, this is trippy. Whoa. This isn't really normal, I don't think. See, if I just do a small one, if I do it here, look how weird that is. That is totally like abnormal. This side's positive. Put the scope back on here. True. So there's the wave there. You're back to that sine wave now. I don't understand it. I don't know how it works like this. Let me hold this side and then touch it. Yeah, it starts to light just from touching it. There's the waveform. When I'm touching it, we're getting that kind of waveform, which is fascinating. It's telling me we're getting 150 volts peak to peak. And then if I let go, it goes to 0. And if I actually connect it, you're only getting 40 volts peak to peak. I don't understand this with a different, but we have a smoother sine wave now without all those without all those high peaks, so without those spikes. So that's a smooth sine wave type of deal. That's it's not completely making sense to me how all this is working. If I just hold this end and then touch the trigger. So yeah, we get a totally different waveform from doing it through my body. I don't know why this is. So that's the waveform with the highest resistance of my whole body. It's just being triggered with those high peaks. At a much lower frequency, apparently. Much lower frequency. And if I connect it, by connecting the trigger to different resistances, we're getting totally different kinds of frequencies by connecting it to different points on all the resistors. We're starting to get different frequencies. And when I go all the way to here, so now we just got 200 ohms. Is that like an RF burn? We go to here. So we're getting this high frequency now, 1.3 megahertz with a smoother sine wave. And we're connected just through this variable resistor now with 200 ohms. So anyways, this has been a demonstration of the Tesla bifilar pancake coil with the VHF, very high frequency transistor that's extremely efficient. It's able to trigger through virtually unlimited resistance which means there's no current. It's able to trigger off of like wireless nano currents. It's crazy. I don't actually know how it's possible, but that is what I like. That's the high frequency. So this is now, the light is on such an insanely high frequency that it might as well be just a constantly on DC. It's switching on and off, or high to low voltage. There's not even an actual on and off exactly. It's not giving me exactly like a square wave. It's giving me like a sine wave. So it's an interesting thing. We're able to power this light at 1.3 megahertz with this, and the voltage that we're at in the battery is come on. voltage are bad. The battery is 5.04. So we've barely used just a tiny bit of juice out of the battery, and we're powering a 12 volt light strip with a decent amount of light. 12 volt light strip very, very efficiently. We've hardly used any energy, even though we're only powering it with the 5 volts in a Joule Thief configuration. So it's definitely very interesting, to say the least. See, we're not using this at all, this freaking piece of junk. We're just using this one little battery pack, and we're using that as a resistor. It's a 200 ohm variable resistor. We're not using all of these, although I can take this and just touch it to even the very end. So, I mean, we're now being triggered with nothing. If you can imagine that. How is it possible to trigger it with nothing at all? And we can see, what does that do? It changed the waveform. It drastically lowered the frequency to do that. Look at that interesting waveform. It's definitely interesting. It's about the same amount of light, it looks like, but it's just coming through in a different waveform and a different frequency. I personally like the really high frequency, but it's a cool little waveform. It's definitely interesting. So I'm literally triggering it through infinite resistors. I can disconnect it and put it in my hand and still trigger it through all of these resistors, through this hand all the way to my other hand, through all of those resistors. So we're triggering on nothing. And if I don't put that in my hand, it triggers a little bit still, based on some kind of charge that's in my body that might be from just the body voltage from the wall wiring, possibly. But if I hold this trigger wire and then do it across my whole body, it lights up a lot more. And you can see the trippy waveform when I do it like that. I do it through my whole arms and all of those resistors, but instead I like it more when I just connect it on here through 200 ohms instead of like a million ohms, or like 100 it was like 800,000 ohms or something crazy. So when we connect it with way less resistance in the trigger wire, it gives us a way different wave at a way higher frequency. Now that's definitely interesting how that works. So that is an actual Joule Thief wave from a Tesla bifiller pancake coil, lighting that light off of only about 5 volts instead of a much higher voltage. So we're still at 5.03, so we've barely gone down. We're just using a very small amount of energy for this. But if I didn't use the Joule Thief circuit right now, then that light wouldn't even be on. Okay, we're done. Bedtime.